Hello everybody, welcome to a new episode of the Dissenter. I'm your host, Ricardo Lopes, and today I'm joined by Dr. Tyler Volk. He is Professor of Biology and Environmental Studies at New York University, US. His areas of interest include principles of form and function in systems, described as metapatterns, environmental challenges to global prosperity, CO2 and global change, biosphere theory, and the role of life in Earth dynamics. Dr. Volk has authored 7 books, most recently Quarks to Culture, How We Came to Be, and we're going to focus our conversation today precisely on that book. So, Dr. Volk, thank you a lot for taking the time to come on the show.
Okay, you're welcome, Ricardo. I look
Okay,
forward.
great. So, I would first like to ask you what is the premise of your book? Because I guess that you try to show how things went from the origin of the universe and the formation, let's say, of the first subatomic particles until the point we arrive at our current human history and culture and the several different types of social and political systems that we have developed. Is that correct?
I've always been interested in nesting of systems. How there's systems within things within things, and I wanted to trace that from the simplest small things that we know upwards to the human body, and then from the human body we are part of social systems. So I wanted to trace a sequence of nestedness.
Mm-hmm. So, were you trying to arrive at a way or a framework to integrate the several different levels of existence, in the sense that, for example, we could know something that, or could understand a phenomenon that is occurring at a higher level by deriving it from lower levels, or was it something different?
In the predictive sense, the larger, more inclusive levels from the smaller levels, but I was trying to understand what was innovative about each level that enabled the subsequent level, that subsequent level could not have been arrived at were it not for that relational innovation that happened on the level right before. And so, for example, what do atoms have that enable molecules to exist, that or come into being and then chemically react with each other to form more molecules, that could not have happened at the prior level to atoms, which would be the atomic nucleus, in terms of nuclei relating directly. And if we go to biology, what was it about as far as we know, there's still mysteries, what was it about the eukaryotic cell, let's say, that enabled complex multicellularity, which we are members of, that did not happen at the prokaryotic cell level, although there are explorations of multicellularity by the prokaryotes of a certain kind, but not complex. And if we go up to the cultural scale, which on my scheme are levels 10, 11, and 12 of this fundamental sequence, this grand sequence, what was it about, let's say agriculture at the agro-villages at level 11 that enabled the geopolitical state, level 12, to come into existence, that could not have happened at level 10, the hunter-gatherer human metagroups. So it's not exactly deriving in a reductionist sense, although that's more true in physics. I mean, this is an issue we could get into. This idea of reductionism is more true in physics than biology. But that gives you a little sense of maybe what I was after, hopefully.
Sure. So it's not because the several different levels are nested within each other that, for example, we can explain cultural or biological phenomena via things or that happen at the level of physics, like, for example, physical laws, right?
Yes, right. Um, Maybe I could just run through the 12 just verbally
Sure.
while I switch to a diagram for people that are looking visually, but I'll also say it. So I call this the grand sequence, with the idea being that each level is determined by combining things of a prior level, which you see here on the right. And this on the right, it goes in a circle or cycle as it's building up levels, with the idea that the earlier levels existed prior and were necessary for the more inclusive level to come into existence. So just for the people that are listening, I'm just going to say them fairly quickly. The fundamental quanta of the standard model of particle physics, nucleons, which the most are important for us, are the protons and neutrons. Atomic nuclei, which are a combination of protons and neutrons. Atoms level 4, which are the combination of atomic nuclei, and then coming up are electrons from level 1 of the fundamental quanta. Molecules, the level 5, which are combinations of atoms, and then once you have molecules, you can have molecules creating other molecules. That's okay in this scheme, just that atoms had to be there first. Prokaryotic cells, this is a big jump because now we get the origin of life. They were well enough established to put them in. The eukaryotic cell is the famous symbiogenesis of Lynn Margulis, the combination of prokaryotic cells to form certain kinds of complex cells. Multicellular organisms, here I'm referring to the eukaryotic complex multicellular organism, in which multicellularity are necessary for the continuance of that species, and the cells cannot live by themselves. Animal social groups, there are many, many kinds. We come out of primate social groups that were probably a fission-fusion kind. Tribal metagroups, this gets a little tricky. I follow the anthropological hunter-gatherer literature here, in which apparently humans, to have culture, have something beyond their local daily group. They have something in which there can be bonding with groups over the other side of the mountain, let's say, or across the lake, by shared cultural patterns or shared language that was necessary to keep the complexities of culture in place. This goes by different groups, sometimes called hypergroups or metagroups, or tribal metagroups. There's various language. And then agro-villages, I find this particularly interesting because plants and animals are brought into our systems as sort of energy organs or energy organ of the human society. And then many, many villages together with certain inventions of expandable hierarchies. For example, you get to the geopolitical states in the ancient world, in Mesopotamia, but they also had primary places of formation in China, in South America, in Mexico, in Egypt. I see our current world, even the nation states today, despite many in these geopolitical states, as a continuation of that level of the geopolitical state. And I ask toward the end of the book whether the planetary scale might be getting into something different. And I'm just going to I just want to say one more thing here. Let's see if I go through quickly. Actually, these 12 levels, the diagram gets reversed here. But this is another, what I consider an important concept, or important conclusion to me, is that these dynamical realms of physical law, biological evolution, and cultural evolution frame these fundamental levels. And what happens is that some of these levels, the jump or the innovation is so significant that the dynamics carry on for subsequent levels of what I call combogenesis. So Ricardo, if it seems appropriate, maybe I'll end the visual now, and we could get back to the audio if that seems fine for you. Unless you have a question pertaining to this, that I might just stay on the diagram, which I'm happy to do.
Sure. Let me just ask you one quick question. Since you're showing the dynamic realms, what is the definition of culture that you use in your book? Is it something like information that is transmitted among or between individuals, in this case of the human species, both vertically and horizontally, that is not genetic? Is it something like that, or?
Well, I agree with the part that it's not genetic, and I agree that there is information exchange among people and then across generations as an important part of culture. But I see culture more, and it's not me, it's certain anthropologists, certain lines in anthropology that see culture as also the materials, the material stuff, the tools that people use, eventually the writing, eventually the plants and animals that are now in the culture, which was very important as part of this transmission. Well, you could consider, depending on how you look at information, you could see that as information. But I do see it as interactions among people, material culture, the stuff that's in between the people, and the use of language obviously is important in human. And then we have to bring in consciousness and the fact that people can have thoughts about other people or thoughts about what they want to make as they're making a tool. It's a very inclusive definition. At least the way when I say the realm of cultural evolution, all those things can evolve. The language can evolve, the material stuff can evolve, the human relations can evolve.
Mm-hmm. Yes, I decided to ask you about that because I was looking at one of the levels, the animal social groups level, and I was just thinking that there's that ongoing discussion about if other animals apart from humans also have at least an incipient form of culture, because when we compare, for example, practices that other primates have, or at least some of them, like for example, some of them use tools for this and that, and they transmit the process of creating those tools to other individuals that are part of their groups, for example. I was just wondering if in this case you were focused mostly on what some people call cumulative culture, that is something that is specific to humans or not.
Right, so I'm glad you bring that up. It's a very important point. So we know that the chimpanzees use tools, crows and ravens can use tools, animals and social groups or sometimes alone can have something called culture in which they're transmitting it by somebody, one individual seeing another individual work a tool in some kind of way. So, and Alex Massoudi, the British expert on cultural evolution, has a recent paper saying that he was really trying to figure out what is it about human culture that is different. Every time we say something is different in humans, we seem to find it in animals. Right. And he cites a couple examples of animals. They're actually birds that seem to have a little bit of cumulative culture. But what the claim is now is that the human culture, something went on in humans because it got so complex. When we go from stone to to jet planes, or some people like to point out the hand axe, the ancient hand axe that now fits in your hand became the smartphone hundreds of thousands of years later, or even longer time period. Evolution looking lineages of these things, so different groups could make the tool differently, and it could progressively branch. That's one thing. that is unique, and the other is the idea of combining. So the hand axe can be combined with a stick and use twine to tie it around, and then that can be made into stakes that get put up around maybe an image of some kind, and people are told not to go there. Or so you can have this incredible complexity, but this is an ongoing debate. The way I see it, Ricardo, is that culture consists of two evolution-like processes, meaning general evolution, meaning propagation, variation, and selection. And the one is what I call cognitive PVS, cognitive propagation, variation, and selection, in which in our minds we can think of ideas, and we can, this is Hunter Art from Australia, we can think of ideas and manifest them, or talk about them with others. And the other PVS is the social PVS, groups getting together and discussing to make group decisions and having group debates, and this itself can evolve over time. The cognitive part, I believe, I make a case for the psychologists that say that animal cognition contains modify the individual's behavior repertoire right within their own lifetime, so that there's a sort of a cognitive evolutionary dynamics in the learning process, in animal learning, and certainly certain kinds of animal learning that are involving experimentation and testing, not scientific experiment, but learning where food is, or learning what's good, what's proper, not proper behavior, as animals are conditioned within their group. So there's a social learning involved too. But what they seem to, I think what really took off in humans is a more advanced cognitive learning that was based on the inherent animal brain processes that could do trial and error learning, that gets put into very complex cognition with humans in terms of how we can think things through in great detail and do experiments in our minds, and then tell somebody, I might have thought a little bit ahead of time, okay, what am I going to do when Ricardo starts asking some of these difficult questions, such as cultural evolution. But then the humans also have very sophisticated social techniques that use language. They have yes and no brought in socially in some kind of way. And so humans get, these are these different words that I found in the literature: metagroup, hypersociality, ultrasocial, megabands, multibands, tribes as bands of bands, type 2 superbrain, or we-intentionality, where the group can have an expressed verbal intention to do something. So these are all the little numbers there. Apologies, this is just a scan from my book. The little numbers refer to specific parts of the anthropological literature.
Mm-hmm. Well, I'm not sure if you have something there that is related to this question. I think you've already alluded to it, but we haven't yet touched directly on the concept of combogenesis. I think that is a very fundamental one in your book, right? So could you tell us about that?
Yes. Right. So this is the book for those who can see for a minute. So the combogenesis is the following idea. Things can combine to form larger things with new relations. Now, in the complexity literature, or in certain literature, this is in general called emergent properties, emergence, but I'm using the term combogenesis for a very particular kind of emergence that I think is very important. And I hope oh man, I'm not sure I have it here. Okay, I have to just describe it then. If you look down into the human body, we're made of cells. The cells had to come into existence prior to the human body. Cells have molecules in them. Molecules had, not all molecules, not the molecules all in cells, but had to come into existence prior to a living cell. And so I use the term only to refer to the genesis of new things by combination and integration of prior existing things in this particular what the human participates in. Now, I should say that some people talk about emergence of light from stars, when stars form from the atoms that combine, and then the star gets so hot, the electrons get stripped off, and you have atomic reactions, nuclear fusion reactions. Yes, that is emergence. Some people talk about water, the qualities of water from hydrogen and oxygen as emergent properties. Some people talk about, let's go back to the jet airplane, of how you put all these parts together and you can, or any airplane, you can, wings with an engine, you can have an airplane fly, you can have something happen that existed in none of the parts. So that's all true. I wanted to ask a particular question. Let's see if I have it here. I wanted to go from the simple to complex in a certain line of a line of logic. It's a subset of all emergence, but I think it's a really important subset because it got to us. And it could not have happened without the stars, without the Earth, but the stars and the Earth are not literally inside us. The stardust from previous supernovas is inside us, so we're made of stardust, but not stars directly. So I was just I'm repeating that I'm following a certain line of logic that interested me to see if I could count and discuss and figure out these fundamental levels.
Mm-hmm. So, I mean, I've asked you about culture, but maybe just going back to the lower levels and, for example, the level of the fundamental quanta. I mean, this has to do with the standard model in physics, right? Is it the case that it's already, I mean, I guess that in science we can't really say that something is completely proven and that people won't find anything new about it, but is it the case that the subatomic particles are already well defined and established, or is there something else that we don't know yet?
All right, good question. So the physicists like to say it's maybe the supreme achievement of the human mind is to figure out the standard model. The physicists will confirm that there are some major mysteries in there. Does dark matter contain other particles? Why are these three generations in the standard model? What determines the masses of the quarks? What determines the masses of, say, the up and down quark and the top and bottom quark? Those right now are just empirically put in, and if they were different, the operation of some of the some of the things that can come from it could be different. So there are still some outstanding mysteries. At the same time, certain the standard diagram of the standard model seems to be really well established.
Mm-hmm.
Okay. Great question.
Well, you know, even when things are already well established, somewhere in the future someone could propose an even better model, so that's why I asked, and particularly if there were some major questions that we haven't gotten a good enough answer to yet.
And what's below? Is there anything below it? Are there are there these supersymmetry, other kinds of mirror image particles, or something within? People have been proposing, inside with the strings, and so I'm taking that. Great, mystery is there. We can change we can modify our description when we need to. But it looks like once you get, and at least in our universe, the things that are known in our standard model, it's fairly well established how protons and neutrons come into existence from the the quarks and the gluons of the Standard Model. So
But,
some of the higher levels seem to be pretty well understood.
by the way, is it the case that any of these particles is immortal in any way, or?
Well, interesting to me. I didn't know this when I began asking these questions of the literature and of the experts I consulted. That the neutron is well known by particle physicists. The neutron that makes up all the atoms the nuclei of atoms that are in our bodies. The neutron by itself only has a lifetime of about 15 minutes, and it will disintegrate into other particles I don't need to go into. But the proton, as far as we know, either is immortal, it will never disintegrate, or what they call is like the minimum times of that are much, much longer than the age of our universe. So they're still seeking that it might be, protons might have a mode of decay, it's called, but so far it looks really immortal. And the cool thing is that when the neutron gets bonded with protons, when neutrons get bonded with protons in atomic nuclei, they then become long-lived because the presence of this of the proton near them, they can't decay into a proton and other particles, or there would be so much energy, so much potential energy would come into existence that it's prevented from coming into existence. So the neutron is given longer life by being in the presence of the proton in the atomic nucleus, which is good for us because otherwise there'd be no biology.
Yeah, sure. That's very interesting. So let me just ask you about another concept that you talk about in your book, that is the alphakit. Could you tell us what that is about, and if it has something to do with something that explains how we go from one level to the next, or doesn't it have anything to do with that?
Well, yeah, it does. So I noticed that in the origin of life with the prokaryotic cell, as is well known, there are four bases of DNA that make up triplets that make up these codons that then make up genetic code, and they code for the 20 amino acids that form what the biologists call a protein space that could be billions, trillions, of proteins, both that are, well, how many currently exist and how many would be possible. These are astronomical numbers. And then people have remarked, human language has a structure in which a few things, in the written language, a few letters can make up, basically an infinite number of words. In fact, when we add the letters and the numbers, we could make up words for all the proteins that are possible. But if you go back before written language, it's the phonemes of spoken language. English has about 40 phonemes. It's more than the letters of the written language because the vowels, it's complex, but the vowels have multiple sounds. Many of the vowels have multiple sounds. So it's approximately 40. That can give us, we typically use thousands, tens of thousands of words. There's hundreds of thousands of words that have been, are there in English, depending on how finely you look at what it makes a word exist. But it could be many more. So I thought, that's really interesting. At the start of the biological evolution realm, the dynamical realm, a structure that has in which a small number of parts lead to almost an infinite number of possibilities, amino acids to proteins, coupled with the gene, with the base, with the DNA bases going to the genes. Those things are actually coupled, but they both have this structure of small number of units to huge number of things that are made. That's similar to the 40 phonemes can make great numbers of words. And that's at the origin of cultural evolution with the tribal metagroups. So I thought, that's kind of interesting, because if those begin a biological kind of evolution, and then a new cultural kind of evolution. There's a relationship between these new, what I'm calling the alphakit structure. It's like I coined the word meaning like an alphabet-like structure, but it's a kit because it's not a thing in itself. It's used by a kit of a small number of parts to almost an infinite productivity of a finite number of elements, a small number that can give rise to almost an infinite number of productions, since it's so important at the origin of, rather than just saying language is like the genetic code, or the genetic code is like a language, I decided to coin a term for that particular repeating general pattern, and I call it an alpha kit, trying to play on the idea of an alphabet, but it's a kit because it's used by the earliest cells, as far as we know, since all living cells have the same alpha kit, the same genetic and amino acid alpha kit, and it's used in human language. Not that all languages have the same 40 phonemes, obviously, but that there's a phoneme word kit in which small numbers of parts can make huge numbers of variants. Why this would be important in systems that have evolutionary dynamics is because it leads naturally to variation, not just to variation, but to a real the possibilities of complex variation. So the fact that the amino acids can be assembled into billions, trillions of proteins to be explored, and phonemes and language can be, if we see something or humans make something, we can give it a name, and it's relatively easy to learn because it's within the phoneme structure. It's just a rearrangement of the phonemes so it's an easy way to have cultural productivity.
So is it the case that each of the three dynamical realms has a specific alpha kit to it, or not?
Well, okay, that's a really good question. So in a sense, the standard model of particle physics, it looks like a periodic table. It's often in a grid, and they sometimes call it the periodic table of particle physics because it gives rise to protons and neutrons, and they give rise to. So the alpha kit, as I define it, is when a small number of components give rise on the next level to a virtually infinite number of possibilities. And so even though the standard model, the things of the standard model are called, the standard model is sometimes called a periodic table of particle physics, at first the productivity is not very high. It's only the proton and the neutron. There are these other particles made from quarks that can be made in particle accelerators that it's a little bit complicated. I don't need to go into it. But then the next level of atomic nuclei, there's maybe 80 something stable nuclei and 90 or 100 that we can make that are unstable. Some of them are unstable, but it's not that many. It's not infinite number of nuclei. And then when they combine with atoms, it's the same number of types of atoms. But then the next level, molecules, going from the atom, let's say 92 kinds of naturally occurring atoms types, pretty small number, to virtually infinite numbers of molecules is what I would call an alpha kit structure. So the standard model had the possibility of giving rise to two levels that are not evolved. They're not even evolutionarily. They are, but they are an alpha kit structure. And then the molecule being this infinite level, within it formed the DNA bases. In other words, this is to me really extraordinary. Within the molecule level, its potential productivity is so huge. It did give rise to an alpha kit structure within it of molecules. So amino acids as small molecules that can combine into large molecules of proteins. There's an alphakit structure within the molecule level, and this was important for life. So I do see three primary alphakit structures. One in the realm of physical law, the atom to molecule pair, that's two of the fundamental levels. Then the next is the prokaryotic cell, the living level, that contains the genetic alphakit within it, built from molecules, and then humans with phoneme to word alphakit structure that gave rise to cultural evolution.
Mm-hmm. So let me just ask you maybe one last question. So we've talked about the different levels, the 12 levels, and also the dynamical realms. I mean, could we expect in the future for new levels to arise and also new dynamical realms? And picking up on the 12th level about the geopolitical states, do you think that we as a species could move beyond that level to an even more inclusive one, or not?
So this is something I am actively pondering. Clearly, there are relations happening that are connecting people with the internet, as you are doing here with your video and podcasts, with global trade, with the carbon dioxide, which country is emitting the CO2. Global warming is going to have to be experienced and dealt with by everybody, and probably with some collective action. So there's all these things going on. So, and logically, if you follow the logic, if the nation state is still within the United Nations, is a evolutionary descendant of the ancient states, similar to the way our bodies, our complex bodies, are evolutionary descendants of worms, let's say, from 600 million years ago. It's still within the level of multicellularity. But when you get complex animal societies, you get a new level. So the question is the planetary scale going to be a new level of combogenesis? We can look. It's not that the nation states would disappear. It's that, just like the cell did not disappear when it became multicellular, or the animal did not disappear when it became the animal society, we might look for certain transformations in it. People are talking about this, but there's debates about, the nation state, is over. I would say no. We look for its transformation as a unit to participate in something planetary, and it might not be. In fact, I think it would not be a centralized government the way the nations tend to have within them, because that would in some ways be a continuation of a centralized authority which has been in existence for the thousands of years since the geopolitical state's been in existence. We might look for a different kind of network of phenomenon, which I personally find very exciting, that thinking in these ways may allow us to stretch our minds into some new directions.
So could it happen, or do you think it could happen, that we in the future might have smaller political units or smaller nodes, but perhaps more interconnected between them, or something like that?
I do, Ricardo. I actually do. Some people have talked about cities taking on a bigger role. My personal, because cities are starting to make agreements with other cities, but my personal way of looking at this is that as we get larger in scale, the individual becomes threatened. And other people will write about this. What is happening to the individual person as these scales get so large, as surveillance is happening, as people start getting known, and how their behaviors get predicted by algorithms that are perhaps manipulating them into being robotic consumers, or to have a robotic side of the consumption, and maybe strengthening local governance systems at the same time as this planetary scale is emerging.
Mm-hmm. Right. Okay, so I think we're reaching our time limit. So before we go, Dr. Volk, would you like to tell people what are some of the best places on the internet for them to find your work?
Well, they can just do a search on YouTube for videos I've made, not just directly on this work, but on some of my other books, Gaia's Body and CO2 Rising. There's been a few. If they just search for me, there's been some about the book. They can get interested. And the standard places to buy the book, they can look for it there. But if they do a search on the internet, they can hopefully find some things of interest about my work over the years. Because I'm very interested in pattern formation in general. We did not talk about Metapatterns, but that was my first book, Metapatterns Across Space, Time, and Mind, looking at recurrent themes across different scales, particularly that occur in biology and culture. And that led to the Quarks to Culture book. That would be an example of a metapattern, because it's a recurrent structure that gets found because it's useful in some kind of way. So that's just a little summary, but
okay, great. So I will be leaving links to I will be leaving links to all of your work in the description box of the interview, so that people can go and check it out. It's very interesting. By the way, I loved the book. So Dr. Volk, thank you a lot for taking the time to come on the show. It was really a pleasure to have you on.
You're most welcome, Ricardo. Thank you.
Hi everybody, thank you for watching this interview until the end. As you might have noticed, I've started this channel in February 2018 and have been putting out regular interviews with academics and intellectuals from a variety of fields. So to keep the channel sustainable, I would like to ask you to please visit my Patreon page and to consider making a pledge there. Any amount, even just $1, would already be a great help. Otherwise, and if you like what I'm doing, please share it, leave a like and subscribe to the channel. You can also support me on PayPal or Subscribestar. All of the links are in the description box of the interview. I would also like to give a huge thank you to my patrons and PayPal supporters: Karen Litska, Anne Blanchett, Perelga Larsen, Lau Guerrero, Chantal Gelinas, Francis Ford, Hans Frederick Sunda, Brian Rivera, Lucas Stafiniak, Sergio Condreanu, Jane Henninen, Ricardo Vladimiro, Craig Healy, John Connors, Adam Castle, Vega Guidi, Olaf Alex, Jonathan Wiesel, David Diaz, Dr. Jerry Muller, Herbert Gintis, Rutger Voss, and Bo Weingart, and also my 3 producers, Isar Webbe, Rosie, and Jim Frank. Thank you for all.